Hi folks, welcome back for the third and final video in your 10.3 lecture series. And in this video, we're going to take a look at substitution and how that applies for Taylor series. Okay, again, we're going to really rely on table number 1 a lot. So don't forget, I will have that for you on the exam. You do not need to put that on your reference sheet. Okay, so let's get started. Find the Taylor series at 0 for f of x equals e to the negative x squared and find the interval of convergence. Now you'll notice that we don't have a note here that says the interval of convergence is the same as your original. So I do actually want to make a point that the interval of convergence can be different from your original. When you're looking at substitution. Okay, so your interval of convergence won't necessarily be the same like it is for your differentiation and your integration. Okay, it might be different, so that'll be an extra step to watch out for. Okay, so example number 6, find the Taylor series at 0 for f of x equals e to the negative x and find the interval of convergence. What does this look really close to on our table? Okay, to me, this one looks like e to the negative x. Okay, so if I kind of blur my eyes a little bit, it looks like e to the negative x, but instead of an x, someone has put an x squared in there. Okay, so we're going to use that knowledge. All right, so let's let our g of x equal e to the negative x. Okay, and we know that the Taylor series for this is 1 minus x plus 1 over 2 factorial x squared minus 1 over 3 factorial x cubed, plus there's an alternating term, so I need that negative 1 to the n over n factorial x to the n. Okay, I also know that this converges everywhere. And when the original converges everywhere, your Taylor series with the substitution will also converge everywhere. But we're going to see in example 7, and I believe example 8, that that's not going to be the case. Okay, so that's why I wanted to preface this with the interval can be different from the original. It's not going to be in 6, but it will be for 7 and 8. Okay, so let's say this now. What if we put, instead of x, we put in an x squared? That sure would give us e to the negative x squared. And so all we're going to do, let me pull up a highlighter for a moment. Everywhere I see the x, so here, 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 I'm going to replace that with an x squared. Everywhere I see that blue, okay? So that's going to look like 1 minus x squared plus 1 over 2 factorial x squared squared. Okay, you see how that blue is like the x and then I'm squaring it? I have to like put parentheses around that x squared, otherwise I might forget to distribute any exponents, okay? So then minus 1 over 3 factorial x squared cubed plus, I keep going, alternating n factorial x squared to the n. And I keep going, okay? So let me get that highlighter back on. This is where I've put in all of my x squared, all right? The most important thing about this is the structure, like being able to see that substitution, okay? The rest of it is algebra, which is also important, like you want to get to the right answer, but like conceptually make sure you know how to simplify or substitute, and then we'll make sure we know how to simplify, okay? So when we clean this up, we'll get 1 minus x squared plus 1 over 2 factorial x to the 4th, because it's 2 times 2, minus 1 over 3 factorial x to the 2 times 3 is 6, plus negative 1 to the n over n factorial x to the 2n, because I'm going to be multiplying the 2 times whatever that power is on the outside. Okay? This is our Taylor series that we're looking for. And because the original interval of convergence was everywhere, we still have the same interval of convergence. Okay? All right, let's try another example. Example 7. Find the Taylor series at 0 for f of x equals 1 over 4 minus x, and find the interval of convergence. This, to me, looks like 1 over 1 minus x, right? If only that 4 were a 1, then we would already know what it is, okay? So let's do a little bit of algebra, okay? So f of x, okay. So I'm going to do this. I'm going to take my my f of x is 1 over 4 minus x. And I'm going to factor out a 1 from the top, and I'm going to factor out a 4 from the bottom, okay? So 1 over 4 comes out. Well, the top still has a 1, but when I divide 4 by 4, I get 1, minus when I divide x by 4, I get x over 4. Now, I know some of us are sitting out there being like, why is she making more fractions? Like, that seems like not a great way to do this. But this is all about matching the structure, okay? So you see how now we have a 1 and a 1 in the numerator. Those match. And then a 1 and a 1 in the denominator. And the only thing that's different is instead of an x, we have an x over 4. What this allows us to do is say we've actually got 1/4 times g of x over 4, okay? So this is my g of x, the one that I'm matching it to, and instead of putting in an x, I can put x over 4, and then I can multiply the whole thing by 1/4, and I will get the function that I'm looking for, okay? But this structure, this is the one that helps us write the Taylor series. So let's find the g of x over 4 first. Okay. Well, what is g of x? So let's not get ahead of ourselves. 1 over 1 minus x. This is 1 plus x squared plus x cubed plus all the way to x to the n. That is my Taylor series, my original. And it only converges between -1 and 1. Okay, so now let's find what happens if we substitute in x over 4. We get 1 over 1 minus x over 4. 1 plus x over 4 plus x over 4 squared plus x over 4 cubed plus x over 4 to the n. Okay, I'm going to leave the interval of convergence for right now. And now I want to multiply everything by the 1/4, and that will get me to what I'm looking for, okay? So 1/4 g of x over 4 is going to be 1/4 times that 1, which is 1/4, plus 1/4 times x over 4, plus 1/4 times x over 4 squared, which I'm actually just going to write as x squared over 4 squared. And here's where it's like, don't write 16. That's not going to be helpful. But 4 squared is going to be helpful. Plus 1 over 4 times x to the third over 4 cubed, plus 1/4 times x to the n over 4 to the n. Okay. Now, this is really helpful in coming up with our pattern, all right? Because what we can actually write this term as x to the n over 4 to the n minus 1. That's like a cleaner way of writing that, okay? All right, well, what about this interval of convergence, though? It used to be this. But then, instead of an x, we put x over 4. So instead of an x here, we're going to put x over 4. All right, so this is going to be negative 1, x over 4, 1. Now I'm going to multiply the 4 to both sides, negative 4, x, 4, and this is my new interval of convergence, okay? So whatever the substitution went in for x, whatever that substitution was, you're going to make that same substitution in your interval of convergence, okay? It didn't matter in example 6 because whether I put x or x squared in here, it's still going to be infinity to a negative infinity, okay? All right, one last example. Let's take a look at number 8. Find the Taylor series at 0 for f of x equals natural log of 1 plus 4x squared. What does this look like? Okay, I think this one looks like natural log of 1 plus x, right? If I let x be 4x squared, it's essentially the same thing. So that seems like a nice substitution to make. Okay, so what is my Taylor series for natural log of 1 plus x? All right, this is one of those alternating ones. X minus 1/2 x squared plus 1/3 x to the third minus 1/4 x to the fourth plus negative 1 to the n over n x to the n. Okay. Oh, sorry, this is n minus 1. Okay. Now this does have an interval of convergence from negative 1 to 1. What are we subbing in? We are sticking a 4x squared everywhere we see an x. That means for our interval of convergence, we're also going to put a 4x squared in there, okay? So let's make our substitution for the function first. G of 4x squared gives me natural log of 1 plus 4x squared. All right, no more x. We're slapping that whole thing with a 4x squared. No more 1/2 x squared. Instead, we have 1/2 4x squared squared. Okay, so this is where we're substituting things, and we are substituting in something that looks bigger, but I think as soon as you stick the parentheses around there, it makes it a little easier. Okay, all right, let's keep going. Plus 1/3 4x squared cubed minus 1/4 4x squared to the fourth. And let's not forget to do the n term. Negative 1 to the n minus 1 over n times 4x squared to the n. Okay. I think a lot of times we put so much pressure on ourselves to simplify immediately, but I know it's more writing, but just write it out. Worry about the simplification later, right? At least you have the right first step. But if you try and simplify in your head and you're making mistakes as you go, then all somebody sees is your mistakes, okay? So show that step, show that work, show the substitution. And then I can tell is that you don't know how to substitute or you don't know how to do the algebra, right? Those are two different issues. All right, well, let's not clean up a ton, but we've got 4x squared plus 4 squared over 2x to the fourth, okay? So this is what I mean by how we simplify. Like, let's keep a fraction, but all numbers together in the beginning, and then combine your exponents. That's like a valid method of simplifying, okay? Plus 4 cubed over 3x to the sixth minus 4 to the fourth over 4x to the eighth. Okay, times -1 to the n minus 1 times 4 to the n over n times x to the 2n. All right. So like I already knew that the 2n, because I'm seeing 2, 4, 6, and 8. And I know that I have 4 to the n on the top, because look at this, 4 to the 1, 4 to the 2, 4 to the 3, 4 to the 4. So it's less about knowing that 4 to the 2 is 16. That kind of ruins the pattern. What is the pattern is that it's 4 to the 2. Okay? All right, now let's come back and do that substitution for our interval of convergence. So instead of -1 sandwiching x, I'm going to have -1 sandwiching 4x squared. And the first thing I'm going to do is I'm going to divide the 4 away to both sides. Okay. And then I'm going to take the square root of both sides. And the square root of 1/4 is actually 1/2. And because we're actually dealing with like the absolute value of this is less than 1/2, I know that if you type in the square root of 1/4, -1/4 on your calculator, you'll get an undefined. But keep in mind, what we're really finding is like the square root of the absolute value. Okay, so that's why this other side becomes a -1/2, and that is our interval of convergence. Okay. So here's your last question all on one page. I hope that the substitution makes sense. I think it gives us access to a whole lot of other things. But again, that's why I'll be providing that table 1 on the exam so that we don't have to worry about that, but rather we can just work with what we have. Okay? Let me know if you have any questions.